Right, now we're all seeing the same. Perfect. Well, hi everybody. I'm Gregor. I'm a software developer here at HPC, and I'll be talking to you tonight about Nova, a tool that we've built here in HPC and Guild to make microservice deployments into AWS super easy and super simple. Right, before we get started into the kind of technical details, a little bit of background about HPC. The office that we're in here was originally the Guild office. Started about 5 years ago or 6 years ago at this stage here in Dublin. Headquarters in New York. And Guild was acquired by Hudson's Bay about a year and a half ago. And with that, kind of the number of banners that kind of the tech organization here is in charge of has grown quite a bit. So besides the website guild.com, so all the websites are basically we're talking about e-commerce. We're talking about selling expensive items to very wealthy people. So guild.com, flash sales, Saks Fifth Avenue, one of the kind of high street retail stores, and also online in the United States. We have Lord & Taylor, which is kind of similar. It's kind of the Arnold's, if you want, of the United States. We have Galeria Kaufhof in Germany and in the Netherlands. And then we have Hudson's Bay in Canada, right? So, engineering in HPC and in Guild. One of the principles that we hold very high is called voluntary adoption. So rather than somebody high up telling everybody what tools to use or what programming language to use, etc., we basically want to kind of organically people to adopt technologies by virtue of voluntary adoption. So kind of by championing your ideas and technologies, you're kind of responsible to kind of grow and influence other people that you work with. So historically, we have like literally hundreds of microservices in Guild. So I'm kind of, although I'm talking about HPC Digital as well, most of the talk tonight will be kind of looking at the Guild perspective of our technology stack. So hundreds of microservices written in all sorts of languages, from Scala, Java, JavaScript. We even have some Go and Rust services running in production. Each of these services is deployed very frequently. So basically, almost every change that you make in Git is kind of ready to be deployed into production. And with that, obviously, there's a need to find a way to make these deployments safe, right? You don't want to deploy something in production that then brings down the site or breaks things, right? What we had in the past was the concept of staging environments. Although, I love my staging environment, has nobody ever said nobody ever. What we've kind of moved towards in the last couple of years is to test as much as possible in production, right? So services rollouts would kind of follow the kind of scheme that you, if you are testing, if you are running your service in a staging or pre-production environment, you would deploy to those first. Then you would deploy to a dark canary node, which does not get any production traffic. And there you can then run integration tests. You can test that the change you've just deployed is actually working as expected. Then the next step would be to deploy to one live canary node. So that is one instance out of your service cluster that is in the production cluster and gets production traffic. But if you were to introduce a defect into the site, only one of the n nodes that make up your production cluster would be affected, and so you would kind of limit the damage if you want. And then once you're happy that you haven't broken anything, then you would deploy that version to the remaining production cluster, right? When we started here in Dublin, 5 or 6 years ago, all of Guild.com was running out of a data center. And about 2.5, 3 years ago, we made the decision to move everything into AWS. And with that, we all of a sudden had like a huge amount of options and possibilities and services that we can make use of in AWS, and basically wanted to make use of them. So with that, the way that we deploy services into production completely changed. When we were running out of a data center, we had only a small number of large production boxes that were running a lot of things. And with the move into AWS, we were all of a sudden able to use very small EC2 instances, and we're able to kind of untangle these kind of huge boxes into lots of small ones. And with that, obviously, the way that we deploy things into production has changed drastically as well. And as we were adopting AWS, we weren't quite sure, how do you deploy services into AWS? We were kind of all new to the technology, so we kind of set out to build a couple of tools. And what kind of followed was like a fairly long history of deployment tools that we've built, and most of them failed voluntary adoption. And what we've arrived with is, I think we're at version number 7 now. It's the tool that I'm going to talk to you about tonight, Nova. And yeah, we have a long history of deployment tools at Guild. Obviously, there were some learnings. What did we learn? First of all, build as little as possible yourself. We started out with fully self-contained deployment tools that basically did everything themselves, and that which were not making use of any of the underlying tools that AWS provided. But that became hard to maintain over time. You know, people wanted to move on to different projects. People were not interested in kind of maintaining these. It was hard to understand what these tools were doing. It was hard to keep them up to date. So one of the learnings was that, you know, make use of open source as much as possible, and use the provided tool chain. So for AWS, use the AWS tools that it provides to deploy services. Love Docker. And what I call the 1 to 1 to 1 to N mapping. That's basically, so rather than running lots of things on one hardware, run one service in one Docker container on one EC2 instance in a cluster of N nodes. That is kind of the mapping. So we're running one thing on one thing on one thing in parallel, in many. So about a year and a half ago, Nova came into existence. So what is Nova? It's basically a thin wrapper around AWS Code Deploy and CloudFormation, and it deploys Dockerized applications into AWS. So it's really just a really thin wrapper on top of these 3 tools, if you want. So the goal, kind of, I'm kind of taking the final step where we want to get with this presentation here tonight up front. So the goal where we want to get is that we have a production setup where we have 2 load balancers, one live production load, load balancer, and one dark canary load balancer that does not get production traffic. And these route traffic to 3 auto-scaling groups. There's one production auto-scaling group which kind of scales up and down as we receive traffic. So if we're in a high traffic situation, there might be 10 of these, and shrinks it back down again as the traffic decreases. We have a canary auto-scaling group which has exactly 1 node in it, and then we have a dark canary node that hangs off the dark load balancer that we can use for testing, basically, right? So our deployment would be kind of from the bottom up. We would deploy to the dark canary node first, run some tests, make sure that everything works fine, then deploy to the dark canary node, maybe let that run for a couple of hours or a couple of days until we're happy, and then roll out to the remaining production cluster. So before we get started, or before we get dug into into Nova, we need to start with some definitions of the tools that we're actually leveraging here. So let's start with CloudFormation. Who knows what CloudFormation is? Only very few. So CloudFormation, besides the process of forming clouds, is a system, an AWS system that describes, creates, and manages a collection of AWS resources, provisions, and updates them in an orderly and predictable fashion. Right? So what does that mean? So we're basically making it possible to provision and manage AWS resources. Right? And there's kind of two parts to this. The first part is the CloudFormation template. And that is basically a JSON or a YAML document that describes all the resources that are part of my system, of my service, right? So these templates they have a couple of sections, but the three important ones are kind of parameters, which is, if you want, like variables or input that you need to provide to execute this template. Then the resources is that's the body of the template, where we describe all the things that we need. So that could be, for example, a DNS entry, or it could be a load balancer, or it could be an auto-scaling group, or a security policy, etc. And then optionally, the template can have outputs, and with these outputs we can actually combine and assemble CloudFormation templates and kind of reuse smaller templates to build up larger ones. Right? So the output could, for example, be the identifier of a resource that was created by this template. Right? And then, the other part is then the CloudFormation stack, which is this template put into reality. So we're kind of grouping parts of our service into the stack. So if we're going back to, oops, excuse me, we're in the wrong direction. We're going back to this. There would be one CloudFormation template describing the production auto-scaling group, or this auto-scaling part. There would be a second CloudFormation template describing the canary, and there would be a third describing the dark canary. Right? So basically, part of the stack is stuff like roles and IAM policies, networking related things like VPCs, DNS, load balancers, etc. And the actual EC2 information, which AMI to run, what security groups to apply to these EC2 instances, auto-scaling groups, etc. Then configuration for the deployment, for Elastic Beanstalk or code deploy, monitoring related stuff. I can set up CloudWatch alarms, I can set up logging, etc. And then also I could even describe application dependencies, like for example an RDS database, or an Elastic Cache instance, or queues, etc., etc. So basically anything that you can create and set up and configure through the AWS management console, I can describe as part of a CloudFormation template. And then the CloudFormation APIs have then operations to create these stacks, update them, delete them, etc., etc. So kind of interact and apply the template to the actual system, right? And all the ones, everybody who raised their hand earlier and said they're familiar with CloudFormation will probably tell you that it's an absolute nightmare to deal with these CloudFormation templates, because they describe the world. They are ginormous and really, really hard to get right, and making changes to them can be very, very tedious and error-prone, right? So that's one of the things that Nova will help us with, right? So next part, code deploy. Code deploy is the move of program instructions into position for military action, but this is obviously not the code deploy that we're talking about. We're talking about the AWS code deploy, which is a service that automates code deployments to EC2 instances and makes it easy to release new features, helps avoid downtime, and handles all the complexities of updating and releasing new application versions. In code deploy, things are grouped into high-level applications. So for our setup that we want to get to, we have one application, And then deployment groups, which is kind of the basically for each CloudFormation stack, we have a deployment group that we're deploying stuff into. Right? The communication between the AWS code deploy service and the actual EC2 instances happens via an agent that runs on each of the EC2 instances. And a deployment happens locally on your development laptop. You bundle your application binary. You provided an app spec, which is the code deploy descriptor if you want, and you upload that to S3. And then you basically tell code deploy, okay, deploy this application into this deployment group, and then it basically instructs the agents on the EC2 instances to download this blob from S3 and upgrade to the version that is in that deployment bundle. And then on top of that, it basically keeps track of the deployment. It monitors that the new version is actually healthy. So there's like a health check endpoint, for example, that it can ping to make sure that the service started up properly. It then handles rollback as well. It passes the configuration parameters that are kind of application specific into the application during deployment. It checks that the instances are still healthy. So if for some reason an instance crashes, it will then basically take care to start up a new EC2 instance and start up a new service, and keeps track of the last revision. So in case of a bad deploy, it would then basically revert back the kind of partially deployed cluster to the last successful revision. Yeah, and this is kind of the kind of workflow that happens with code deploy under the hood. So you have on your local development machine, you create your deployable content. So that could be anything that can be run on the command line. So it could be, in our case, it would be a Docker image, but it could be anything really. You provide an app spec file that basically tells code deploy what commands to run during the kind of install phases. There's like 5 or 6 different phases. And then you bundle that up into a tar.gz file, upload it to either S3 or GitHub, and then instruct code deploy to deploy this. And code deploy would then talk to the agents on the EC2 instances in that deployment group, and tells them to kind of download this and install it and roll out the new version. Docker. A person employed in a port to load and unload shit. Not the Docker we're talking about here. We're talking about the open source platform to provide basically a container architecture, an abstraction of the operating system, and allowing us to run containers on top of any kind of operating system in virtualized Linux. So it's very lightweight. It reuses a lot of the host OS resources. So other than like a VM, like VMware, for example, that is a very heavyweight virtualization architecture. Docker is very lightweight. It has process isolation. So if a process in one Docker container crashes or does something bad, in most cases it doesn't affect things running in different Docker containers. One of the concepts of Docker is to run anywhere, so I can build a Docker image on my laptop, on macOS, and run it locally, and the same Docker image would also run in a completely different host OS in a production system. And ultimately, beside all this kind of OS-related, process isolation and whatever, it's also simply a very nice way to package applications, right? So I can take any kind of base Docker image, make some modifications to it to create a new image, and then use that to kind of build my application. So how this Docker image ultimately is built is totally up to you, up to the user. So you can have a Docker file in your service. You can use SDT native packager, but ultimately you're somehow building a Docker image locally, and then we're using Nova to deploy that, right? And ideally, you want to use a reasonably lean Docker base image, like Alpine Linux, for example, just because we're uploading quite a lot of, basically the entire image, the base image, plus all your service dependencies. So that could be like a JDK, for example, if you're running a Java service. That all gets bundled into one artifact and uploaded to S3. So depending on how many dependencies your service has, that can get reasonably big. So by using an Alpine Linux, which is kind of very trimmed down, we're reducing the size of the uploads. So let's do a bit of a deep dive into Nova and all the parts that make up Nova. So we're starting out with a somewhat customized AMI. So an AMI is the machine image that basically the EC2 instances would run. So this is all open source on GitHub. You can take a look at that. And what we're doing is basically we're taking a base Amazon, like a stock Amazon Linux, and then we're installing a few additional things on it. So that includes the things that we just mentioned, Docker, the code deploy daemon. These are kind of the bare minimums. In our case, for our Nova AMI, we're also installing the CloudWatch logs daemon, a KMS S3 tool that I'm going to be talking about later, and a couple of scripts that do log rotation and cleanup of Docker images. But these are kind of optional. So if you you don't have to use this Nova AMI. You could feasibly build one yourself. The only hard dependencies that we have here are that we have an AMI that has Docker and the code deploy daemon installed. And ultimately, these AMIs are built using Packer.io. So the second part of Nova are the shared templates and a descriptor for your concrete service. These shared templates, again, are somewhat optional to use. You could feasibly roll your own. But whether you use the ones that Guild uses or you build them yourself, these templates are basically, they describe all the reusable parts of your microservice deployments. Anything that's kind of agnostic to your concrete AWS account, for example, or concrete to your service, goes into there. So it's basically these are CloudFormation templates with a lot of parameters, with a lot of variables that need to be provided. So they kind of split into different types, if you want. So we have templates for an auto scaling stack that grows and shrinks as for example, the load or some sort of a metric tells it to scale up or down. We have a canary stack, which is a stack that doesn't have its own load balancer. It kind of attaches itself to a load balancer of a different stack. We have a standalone or general stack, which we're using for the dark canary instance, so that it's not auto scaling. It has one single instance with a load balancer and a DNS entry, etc. There's different templates for services with HTTP or HTTPS endpoints, and there's templates that either use an internal non-public load balancer or external. So depending on whether your service actually receives traffic from the outside world, you would use the external load balancer template. If your service is kind of a backend service that only receives traffic from other services that are part of your system, then you would use an internal load balancer. So you would install these templates into your home directory, and not sure what I was thinking about that. So the one part is the shared templates, and the other part is then your service-specific nova.yaml. So as part of your service, you have nova.yaml, a file that defines all the kind of stacks that you want to use, and they then provide, they reference, each of these stacks references one of these shared templates and provides all the moving parts basically that are specific to your service and or your AWS account, like for example security groups and the likes. And you know, there's configuration for CloudWatch logs in there as well. And then the third part, the kind of biggest part of the whole of the Nova universe is the CLI. So that is basically a bunch of Python scripts that run on client side on your laptop, and there's kind of two commands to Nova. One is to create and update your stack. So that was there. You know, we were interacting with CloudFormation, and then there's commands to deploy new versions of your service. So it's run Nova deploy and then provide the environment and the stack and the version that you want to deploy. So as I said before, the unit of deployment is a Docker image. How this Docker image is created is outside the scope of Nova. So whether you, as I was saying before, whether you use like a Docker file or SPT native packager is one of the tools that we use a lot for our Scala services. It doesn't matter. You're creating a local Docker image, and then you're basically instructing Nova to upload that into S3 and start a deployment into that stack. Right? So yeah, we don't need a Docker registry. We're creating the code deploy bundle directly locally on the laptop, uploading that to S3, and then basically let code deploy take it from there and deploy that service into production. Right? And yeah, we're doing mutable deploys. We're not trying to spin up a new cluster while the old one is running. We're basically the philosophy is there's basically the deployment of your service should be pretty fast. So you know, your service shuts down, you install a new version, and the new service starts up within a couple of seconds or minutes. So as you know, as part of the deployment, we're kind of going one node at a time, shut down the old version, download the new one, start it up again, and then once that is done, we move into the next one. So putting all the pieces together. We have a little demo service, something basically a hello world service. It has two kind of health check or ping endpoints that we're using with the load balancer, the ELB, to basically check that the service is running. So we have like a head and a get endpoint that we're providing as a health check. And then we have kind of two payload endpoints, one that just does a hello world, and another one that kind of keeps our service busy, you know, ups the CPU usage a little bit, so we can use that to simulate like a scale-up scenario, a scale-up event. Yeah, like shown before, the stacks that we're creating are as follows. We have a dark canary stack, we have a canary stack, and a production stack with two load balancers, a live load balancer and a dark load balancer. So the Nova YAML that we're creating locally for our Hello World service listens on port 8080. We give it the health check endpoint. We're giving some configuration about the log file location. So there's the system log we want to have available. So this is basically how we're getting the log files from the EC2 instance into CloudWatch logs for search and archival and figuring out what's happening in the service should it die, for example, right? So we have the system log that we're sending to CloudWatch logs, and then we have the application log as well, and we're just basically giving the locations of these files. And then we're setting up one environment. This is kind of our AWS account, if you want. We say which region we're in. We give it an IAM role that basically has permissions to set this all up and invoke code deploy. And then we give it an S3 bucket that Nova uses to upload our deployment bundles to. And then, so the application ID, this is the code deploy application ID that will be created as part of creating that stack. So we need to kind of fill that in later, it's like a TBD. And then, as the lower part of this Nova YAML, we define our 3 stacks, right? So the first stack we're creating is the Dark Canary stack, we call it Dark. Here, so we're using the general stack template, so that doesn't have any auto scaling. We have like a single instance with an ELB and an HTTPS endpoint. So this basically tells Nova which template to use for this stack. We're giving some Docker deployment arguments. Ultimately, we have another blank here that we need to fill in, which is the code deploy deployment group. We're telling it the security groups to use for the instance. So here we're using these 2 security groups. Basically, say allow access from the internal network on the SSH and on the SSH port 22 and also port 8080, which is the port that the service is listening on. We give it 2 subnets, so this is the two availability zones that we want to run in the US East 1 region. Then we give it the load balancer subnets, which is also US East 1 and US East 2. US East 1 availability zone A and B. But public facing, so that the load balancer is able to receive traffic from the outside world. We're giving the ELB a security group that allows it to receive traffic on port 443, the HTTPS SSL port. We're providing a key name that we can use to SSH, like an SSH key that we can use to SSH into the EC2 instances in that stack. We give it a DNS entry to create an SSL certificate for our HTTPS endpoint, and then ultimately the Nova AMI and the instance type. In this case, we're using a T2 Nano. The second stack is our production stack. So this is the one that scales up and down. So differences here. So most of the things are the same. The differences here is we're using a different stack template. This is the auto scaling template that allows us to provide a metric to dynamically scale up and down. We're saying so the deployment rollout here, the way we're deploying here is one at a time. So rather than deploying a new version to all of the instances in the cluster, we're basically going one after the other. And then we're providing some extra config here. So there's obviously a different DNS entry because this is our production endpoint. And then the kind of auto-scaling configuration, the minimum and the maximum number of instances. And then ultimately this is kind of reversed. We're looking at the CPU utilization to act as a metric to scale up or down. And we're saying if the CPU utilization is below 3%, then scale down. And if it's above 6%, then scale up, i.e. add another instance to the cluster. The reason why we're using these 3 and 6 is we're also running on T2 Nanos, which are kind of CPU credit based. And these EC2 instances get CPU credits based on an average CPU usage of 5%. So by setting this scale up and down thresholds here to 3 and 6, the idea is that on the long run we're averaging 4.5, so that the median between 3 and 6 is 4.5. So we're kind of below the 5% at which we're getting CPU credits assigned. So we would, with this configuration, on the long run, we would not run out of CPU credits.
Are you using these type of software in production?
Yes, absolutely, yeah. And finally, our third stack is the Canary stack. So again, different stack templates here. Difference here again is basically, the only difference here is that the load balancer is the one that we're referencing from the production stack. So we're saying we're getting the load balancer from this guy. So we're using the same. Right, and then we're invoking CloudFormation. We say Nova stack create, and that will then take our local Nova YAML, take the templates that it references, and passes them to CloudFormation, and then CloudFormation will go off and create the entire infrastructure that we've specified. But there's nothing running in it yet. So we created a couple of empty boxes, if you want. So like EC2 instances with nothing running on it. So now we need to actually release our service. So say we're ready to create our version 1.0. We tag it. If we're using a Scala service with SBT, we can say Docker publish local, or we can use Docker build. So this is what I was saying before. How the Docker image is built is totally outside the scope. But as a result of this command, we have a local Docker image, and then we run Nova deploy, and then instruct it to take this Docker image, upload it into S3, and trigger code deploy to deploy it to the dark stack, right? And then once that is okay, we can deploy the Canary stack, and once that is okay, we can deploy the production stack, and we're done. And then once we've kind of seeded each of the stacks with an initial version, we can then gradually roll out new versions. So for example, if version 101 would be the next one, I could deploy that to the dark Canary first, and then after some time to the Canary, and then to the production stack, and so on. So once we've deployed our service, we have version 1.0 in all the stacks. All right. Time for a live demo. Do we have time? Yeah. Do we have time? Yeah? Yeah. Okay. So we've already written the service. Actually, can you guys see that? I'm going to go a little bit bigger. So I do to make sure I'm logged into. I have to make sure I'm logged into. So maybe just to look at the so all that I have in my service is I have a service, an SBT to build file, and then I have my Nova YAML here, which is the one that we're just going through. So I want to say Nova stack create build AWS. Then we switch to the AWS console. So we can make sure it's in there. We can now look at CloudFormation, and we see that our stack creation is in progress, so it's not quite there yet. So we see there's a hello world. That's kind of the parent stack that doesn't actually contain anything. It just references the 3 actual stacks underneath. But now we see there's a production stack that's being created, there's a dark stack that's being created, and in a second we should see the canary stack being created as well. So we might need to wait here for a second. It's probably the canary stack can only be created once the production stack is complete, because it references the load balancer from the production stack, right? While we wait here, we can quickly go back to the console and create a release of our service. So we say git working. Tag. Okay, and then we do sdt docker publish local. So we're creating a local Docker image with version 1.0. Okay, so Docker environment setup. Okay, let's try that again. Okay, so that's building our Docker image. So if we do Docker images now, we'll see there's a hello world 1.0.0 that was just created. 169 megabytes in size. So let's go back here. There's not much happening here yet with the canary stack. So maybe while this is happening, we can take a look at so what's happening in EC2. So here we're seeing, if we look at the load balancers, for example, we should see 2 being created. So down here we see our hello world. Hello world. This one. Look at the tags. This is the production load balancer, and here we see the dark canary load balancer. Look at the auto scaling groups. We have 2 so far, because we're still waiting for the canary to be created. If we look at code deploy, here we see a new Hello World application, and that so far only has the dark deployment group in it, so there will be a production and a live canary deployment group in there in a second. What else can we take a look at? We can take a look at the DNS entry. So if we go to Route 53, we should see there's a Hello World dark and a Hello World production DNS entry. So that's all done. Let's see where we are here. So production and dark are completed, and now, rollback in progress. Something failed. That's not good. Production deployment will. So for some reason it wasn't able to create the canary. The security groups must have. Right. I guess in the interest of time, I might stop the demo here. Yeah, so unfortunately it's rolling back now. Something failed in the creation around the creating the ELB security group. So maybe there was a typo in there and that didn't exist. I don't know. I'll have to double check why it was failed. That should have all been there. Okay. Right, so the last quick thing to look at, secrets management. Who can keep your secrets? So most applications need some form of credentials, passwords, access tokens, some sort of secret that that we need to provide to the application to run. And one way to do that is you could just hard code that in some config file that you have as part of your application, or you hard code it in your code. But then everybody can see that secret, right? So we want to kind of control access and avoid that these secrets are being leaked. We want to share them across multiple systems so that the database password, for example, is available for all services that need it. We want to be able to rotate keys in a controlled way. We want to control, as granular as possible who has access to these secrets, and we want to make sure that, for example, if an employee leaves the company or changes teams, that they lose access to these secrets, right? So for that we use an AWS service called KMS, Key Management Service, that allows us to control encryption keys and encrypt data, and it provides an SDK, an API to integrate encryption keys into your applications, right? So how does it work in practice? So we have some sort of a configuration file that contains, for example, a database password. And we have a developer that gets an encryption key from KMS so that the user has permission to use that key, and then encrypts this file locally and uploads the encrypted file to S3. And then the service that wants to use that configuration file or that password also needs to have permission by virtue of IAM roles to get the decryption key. So it gets the key from KMS, gets the encrypted file from S3, and is then locally able to decrypt it and access the password inside. And in order to make this kind of workflow easy, we've written a little command line tool called KMS S3. It's a program that's a binary is available for Linux and Mac. It is bundled with the Nova AMIs, and with that you can with a simple command you can upload or download and encrypt and decrypt files. So you would basically just give it the RN to the key, the KMS key that you want to use. You give it the S3 bucket and file to read or write to, and then the local file that you either want to read from or write to, and then the command either to put, to upload, or to get, to download. And that's all I had to talk to you about. If you want to try it out, get Nova. It's all open source. It's all in the Guild org on GitHub. The Nova CLI, the shared templates, and the AMIs. If you want to take a look at the demo, that's on GitHub as well. And finally, if you need help, there's a GitHub channel where you can ask questions. Thank you very much. Any questions?
Just one, so we get the slides right?
Sure, yeah. Sure.
how do you guarantee that secret from this secret storage cannot be retrieved by any other service?
Pardon?
If I have another service, I'm out of a bad service, and I want to steal the key from this storage.
Well, you need to get hold of an IAM role. Your service needs to be running with an IAM role that can actually get the decryption key from KMS, right? So basically, it's using IAM to control access to keys.
Protected by Amazon.
Exactly. Yeah. Correct.
How do you handle migrations?
Migrations.
Yeah,
in terms of
like schema migrations.
Pardon?
Like in the database.
Schema migrations.
Like if you need to change a column in the database, for example.
A database that your service talks to, or
Yeah.
I mean that's outside the scope of Nova, right? But I mean generally you would make a partial schema change that is backwards compatible, then deploy a new version that is able to deal with the before and the after state, and then deploy or then make a second schema change that will then basically roll to the new state.
Do you have folks in Nova to do that, or?
No, there's nothing to do with Nova.
Is Nova currently focused solely on EC2 deployments, or do you have anything regarding on?
No, you wouldn't deploy Lambda to that,
Is the auto-scaling feature based on something that Amazon already provides?
Yes, auto-scaling groups are part of Amazon, correct, yeah. So for an auto-scaling group, you give it a CloudWatch metric, basically, or CloudWatch alarms that basically tell it to add an instance or remove an instance. Yeah, it's all part of the AWS toolchain, if you want
how difficult is to debug an issue that was deployed?
Well, as you know, like what we were just looking at here, where this fails, you get reasonably good errors. So it's fairly clear what happened here. So the ELB security group was missing or was incorrect. So we need to look at what happened there. But it's fairly clear what happened there.
Any plans to provide like as a service, so we don't have to like deploy our own or just use yours? Nova.
Nova I can't see how that would work. And ultimately, Nova is just a bunch of Python scripts, if you want, right? So it's a command line tool that you run by yourself. I don't see a way how this could be done in the service.
But we have to host it in VM.
You don't have to host anything. No, there's nothing that needs to be hosted. We're basically just making use of the AWS toolchain. We're just providing a thin wrapper on top of that. Right? You need to use AWS, yes. Other than that, that's all.
Okay.
Cool.
Yeah.
Thanks.
Thanks a million, Gregor. We'll take a 15-minute break and then we'll be back again.